Thanks for joining me in this talk today. Surprisingly many people for the last part of the last day of the conference. So I believe the strongest survivor can get to this point only. And you are many of them, so congratulations, you are amazing. And today's topic is performance. Despite the name of the talk is Flutter performance, and will base on the Flutter examples, Flutter cases, and so on. I would love to make this session something more, something that will give you not only Flutter tips to make performant application, but grow with you and build with you a generic engineering idea to build performance application. And make this that's a way that you can use it in any technology in which you will work and create performance application. But before we start, let me introduce myself briefly. My name is Mikhail Zotyev. I'm a software engineer with over a decade of experience in different technologies. So lately, I'm working with a Flutter, about 5 years probably already, maybe more. So I'm Flutter and Dart GD, organizer of Flutter Voronezh meetup community. Also, really like open source. I have some personal project which I maintain. Apart from that, I also try to support others' projects. So yeah, I also have an educational channel about Flutter, Oh My Flutter, and recently started recording also videos for YouTube. So on the slide, you can see this weird nickname that you can use to find me in every place where it's convenient to you and where, of course, I'm registered. So, and that's it about me, and let's get the party started. So, performance. Performance is crucial. It was crucial, it is crucial, and I believe it will be crucial always. It's a really important topic. Back days, it was important because of hardware limitation. So developers needed to squeeze every drop of performance to be just normal. In nowadays, it's a bit better because we have really performance hardware everywhere, and we can be not so accurate on this topic, but yeah, anyway, we need to be, and because it's not anymore hardware limitation, it's user demanding. Users get used to good application, really smooth flow, amazing animation. And if you have any problems with performance, it will be ruined. All of this aspect will be ruined by bad performance. So, and any application has many competitors. So if you do not care about performance, believe me, your competitors will believe about that stuff, and users will choose them instead of your application. So we need to care. How to care? So, and the first thing which came to mind, so maybe someone already solved this problem, and I can just reuse those things. I can find an article, maybe a talk, a video, or something, recommendation that I can use. I believe in this conference also, there were already a bunch of talks about performance, not only mine. So yeah, but if we talk about the general ways of all those things, it usually goes in a few directions. The first direction is you find something marketing. In this talks, articles, and so on, you will see the main idea of Flutter has internal magic. You don't need to care about anything, and Flutter will solve everything instead of you. So yeah, Flutter is good, and it can forgive you a bunch of mistakes. Yeah, it's definitely true. But you cannot just give up on the performance and think that Flutter will solve everything. Another idea is we are not here yet, but soon something will be changed because of anything. I don't know, WASM, maybe Impeller, anything. That maybe AI solve instead of us. But it's the same marketing thing, but so it's not so helpful for get performance application. And what you can find else is just a bunch of advice. Do this, or don't do those things. And usually it's just a recommendation. You can follow them, you can ignore them, but it's hardly to choose what to follow on and what to ignore, and sometimes they even in a contradiction to each other. So you can find the few advices which will be advising you to do different things, like completely opposite, how to choose them. And I believe here are many people who work long time with Flutter. So please raise your hands, those of you who work more than 1 year. So yeah, you already have opinion on like almost everything because you work for a while with this stuff. But what if we talk about the person who like recently start? So how to choose? Or you switch technology and like in another technology you also need to make some kind of choose. So let's do this exercise. We will like forget about our personal opinion on all those topics and try to stand in the shoes of a person who worked with the Flutter 1 week, 2 weeks, maybe. So it's enough to read documentation. It's enough to read something, maybe hear some opinion, but it's not enough to get personal opinion about those topics. So how to do in those circumstances? And the first thing is really straightforward, to be confused, but somehow it's also arguing topic. So does const solve something? And if we use const, we'll get an amazing performance, or we can just give up on them and just ignore completely, and nothing will change. So yeah, for quite a long time, we had like generic opinion about if you use const, you will get an amazing performance. And that's it, that's enough. But recently, we got this. So the issue, like investigate if const is enough. And we need to enforce people to use const. So a bunch of lint rules that quite for a while already in the official lint rules list. And as a result, remove these annoying rules. And this is a commit that removed those rules from official list. And immediately an X or Twitter, if you want, started a heating discussion and jokes about like, was it wrong? Why it was there? Like so many times I rejected a job position because I said that it was make no sense and people think differently. All this type of talks. So how we need to decide for ourselves. We didn't reject it yet. So we just too weak in technology. So like, should we use const or not? It's a complicated decision for a person. So I would like to start from the analyzing like why it's happened. So if we carefully read the decision, the issue in which it was happened, so we can get know that it was a benchmark that showed a good performance boost, about 15%. Like no one will decide just ignore 15% of performance boost. But at the same time, there is another benchmark, different benchmark, which trying to measure the same thing, and it shows doesn't matter. So no performance improvement. And how it can be possible that's two benchmarks trying to measure the same thing, almost the same thing, and completely different result. So yeah, in general, I would say that possibly one of benchmark could have a mistake. It's possible. In some cases, not this one, but it can be data manipulation. So someone trying to push some idea and just doing stuff like this. Also, like possibility in different cases possible. And maybe those two benchmarks, even if they look similar and measure the same thing, maybe they measure different things. So how to analyze those benchmarks? And here I would like to recommend another article from Vyacheslav Egorov. So in this article, he brings an idea from another book. So yeah, infinite loop of recommendation. So the idea that benchmarks are experiments, and without analyzing those experiments, validation of those experiments, they are useless. So yeah, this is a really good idea that you need to bear in mind that the experiment by itself is just an experiment. So let's have a look on those experiments. First experiment that was initially showed a good performance boost looks like this. There's a bunch of sized blocks, one in each other. So I think it's pretty artificial. It's generic one. So definitely no one has this. If someone has in a normal application, please raise your hands up. Yeah, someone will blame you. I will not, but yeah. So definitely it's not something that you work with, right? But the second one, maybe it's probably better. So it's already application. So it's close to our day-to-day work. But what kind of application? It's Flutter Gallery. Does anyone knows what is Flutter Gallery? So yeah, I believe, yeah, many people knows. So it's a showcase application, right? So there is not a business logic or something. This is a bunch of Flutter widgets which you can check. You can just try to understand what they do and so on. And important part of this that consts were removed from the application, not from framework. So all optimization of consts that exist in framework, which this is a showcase of, they are still in place. So what we can fairly say, that both benchmarks, they just show us, like, again, idea that we cannot use to choose our own decision. So some cases can be affected, yeah. So we can have a boost of performance with a 15%. Some cannot. How to do in this case? So any idea? How to decide which side to choose? The last one, the first one, someone who louder than their opponents. So yeah, for me, from engineering perspective, I would say I need a personal investigation experiment, analyzing those experiment and decision that will work for me. So, and the first thing which I need to understand is, yeah, what to measure, what is const. So at least I had 2 weeks, as we already know, to read documentation, and I can briefly understand that const is something pre-created on compile time that we create object and then can use. So it should be enough, but let's try and measure, is it completely true? Maybe it's something just, again, generic idea that helps us to understand. Maybe there is also something interesting. So first, start from this behavior. And to measure this, we have everything apart from what to measure. So we create this test class, which has only string value, and simple application. So material app with almost nothing, one test page which has 2 different content. One content is this empty class with a placeholder. Another for our experimental classes with different values. 2 class have the same value. And we use their values in just a column, just showing the value of those things. And if we run this and run our DevTools with the memory profiler, we can see that being on this page, we can found 4 instances of our test class. So yeah, it's predictable. We created 4. We have 4 here. And if we go to another content, to this placeholder part, and the garbage collector works, we do not see this test classes anymore. So they are created, they are destroyed. Normal process, creating, releasing resources. So let's try to make this const now. So 2 options. First of all, we create not const, but class fields, which contains const values. And the second option, we create just normal const on the class level for those things and check behavior. They are both here because the result will be the same. So as soon we run this, we have now 3 instances because 2 of them had the same value. So they just reuse one object in this case, and that's it. But when we go to placeholder part, and garbage collector works, it cannot to destroy those things, so they are keeping in memory. Okay, sounds really similar that we had in documentation. Maybe a bit more experimenting. So what happens if we do not use those consts? So we create them here the same as what it was, but we just remove using of those consts. Run again and see that here nothing. So we, despite that we named them as a const, did everything, they are not created. So our compiler is smart enough to track that those values, they are not used. So we can just ignore them and do not create even. So based on this, we can say that probably there is interesting optimization that we can also investigate and try different combination and see how it works in a different circumstances. Okay, let's make this public. In the previous case, it was private. Maybe because of this, compiler could just understand that it's one class in which it can, one file in which it can be used. So we can just do it a bit more public and check. Nothing changed. Nothing changed. So compiler still able to track all those things and keep efficiently. Okay. Next option. We move them from the class level on the top level. Maybe this will keep them always in the memory, even not used. So no. And what if we put const not there, but in both of them, both of those widgets we created? Maybe something changed, and yes, something changed. After we make const widget in the place of using, in both cases, this test class appears in the memory profiler. So it's somehow have a different behavior in these cases. Okay, another experiment. We always before started from the same page. So one page on that we have a few content that we changed and so on. So if we have a bunch of pages, how it will work in this case? So we add additional thing which contains nothing apart from button to go to our previous page. And yeah, let's make first a final field with the const value and check behavior in the memory profile. In this case, when we being on the new page, we don't have anything apart, even if we have this first and second widget, which still already in the memory. Those things which we created and put in a final field do not create it. We go in this place, and we have three instances, so they work as a const in this case. Optimization is here, but when we left this page, it's already didn't removed after garbage collector works, even if it was in a final field. So yeah. Next option, another experiment. Let's make this the same using, but let's move them again as a top level constant, private but top level, and they immediately appears. Doesn't matter if we go to that page or we still being on the first page which we created, they are immediately there and they are not removed after garbage collector works. Yeah. Yes, I think so here the same option, we just again move them as a const to class level and still using them. 3 immediately in the first page, which doesn't somehow affect those things which we are changing. And let's create additional class that indirectly use the same value of the constant. So we have 2 here, the same value, and a new one here. Both, all of them are used. So here we see that they all appears in the memory profiler with the additional class. And but that class was used, right? So if we check this, I added here a button to go there. So yeah, somehow used. What if it's unused class? And we add unused class in which we use our value here. So compiler could understand that this class is never used. So, but it added a new instance and keep it in memory. Now it's 5, but it was 4 before. Make this private. Maybe it will help to compiler. The same 5. Okay. Let's create separate class again, completely unused for now, just for different const, and those const that's on static level, and apart from this class has instance fields which reference those const. We can see that only 4 that we had before. This class is not affected. But as soon we add here const constructor, let's check the same thing. It's already 6. So const constructor, only existing, somehow changed the opinion of compiler about this to get all those things. So why I showed all those things? That's because, yeah, like general idea was simple and it's totally match with what we see in documentation. But apart from this, we have a bunch of optimization which could work in a different way. So it's a generally complex topic. But how it can affect our performance? Oh, yeah. Also, bunch of other cases. We can see here the static reference of getter, which is not used in this case. It's adding a new one. The unused getter, which referenced the class getter, and there is nothing. And used getter value from here, which makes it also appears both of them here, even if yeah, it's only here used. Before we get there, even like this. So advantages and disadvantages of all those things is we can say that yeah, they anyway work as we expected. So they are created in some compiler time with optimization and so, but previously, and keep memory. So what we can affect? We can affect memory and CPU time. Memory we affect in a negative way, because as you can see, we can just have a bunch of objects which we will not use, we will not get there, but they are in the memory. And CPU, in opposite, in a positive way, because we do not create objects, we just have them prepared. So, but as engineers, we cannot fairly say like this positive, negative, how big it is, right? So we need to, based on numbers, our feelings means nothing for performance. So let's try to measure this. And to measure this, oops. Yeah. Okay. Okay. How to measure this? One object measurement is also relative thing. So we already see the size of 4 or 5 objects, but we cannot fairly say if they grow enough how it will be affected. So simple application, empty, almost empty, just for run this. And if we run our memory profile, but in this case we will turn on all instances, not only our application instances, but all framework and so on, and analyze what we see in this empty application. In this empty application, we see hundreds of thousands objects, and they take just few megabytes. So in modern device, it's almost nothing. So we can say that memory is not affected, even if we create I don't know, 20,000 of objects which always will be in the memory. Those small objects, they not so affect our performance. And what's about CPU? So creating an object. Yeah, so sorry, it's drop in the ocean. Doesn't matter to measure this one object, right? So maybe we need to think about at least like bunch of objects. But which bunch of objects? How many? 10, 100, 1,000? Like, what does matter? So let's recall something that we definitely have seen during the reading documentation, right? So we know this framework part, and we should know how Flutter in generally works. So periodically, engine part ask framework, give me something to show. I need to show user. And engine returns scene, the object that describes what to show to the user. And it happens in 1 second, 120 times if we want 120 FPS, or 60. And those amount of time that we have, it's a frame budget, time budget that we have for every frame. And during this frame budget, we need to work with the business logic, with animation, build, layout, paint, even rasterization, which is already in engine, but anyway. So it all should fit on those time budget. And yeah, so which amount of work we need to analyze to understand that our constness will affect it or not. So probably let's think about the case when we build a complicated screen from scratch. For example, we opened the screen, right? There was no screen before, and we want to show this. In this case, we need to build all subtrees, build elements, render objects, prepare those things, and so on. And during this operation, we operate with 1,000, maybe dozen of 1,000 objects which we create. So definitely we will not have this amount of every frame created objects. So maybe additional 100 if we will ignore those const. So not so much. And we can say that CPU is also doesn't affect it almost. But this all only if we talk about these two aspects. If we talk only about the language design. So, but apart from this, Flutter is a framework. It has its own implementation. Maybe we could experiment with Flutter. So yeah, let's create also another experiment. In this experiment, we'll have an application, simple application with some deep structure. Deep structure, we will show bunch of nothing, sized box container into each other, and the button that will make a rebuild of this. So, and measure efficiency with and without const, like this. And surprise, surprise, somehow it's changed and changed significantly. So this is without const, and this is with const. Let's try to understand why. So we know how Flutter works in the term of building from scratch. So we get this, the heavy part of our building. So we create all elements, build subtrees. For some of those objects, we create render object and then show. But what happens when we rebuild those things? In element, there is a method perform rebuild, which leads to update child. So we need to read a bit of internal code of Flutter. So, and here we have a few branches how it can be possible. That's we completely destroy our subtree, or we can update it somehow. An update can be in a two direction. One direction is it's exactly the same object here, and this is small amount of things. And here case when we not exactly the same widget, but we can update those parts. And the difference between them and this small line, of course, it's minified code, so you don't see this as sorts, comments, and so on, but I left only important part of those things. So here, this child update. what is child updates? Let's have a look on few most popular which you always use. Stateless and stateful widget, stateless element, stateful element. Both of them have this rebuild force true. So if you have not exactly the same object, which const allows you to have, because it's exactly the same object, we have seen that we use two the same values and they create only one instance. So you continue rebuild subtree. But it was a bit hidden ploy inside of this thing. Maybe someone caught this. Did someone what I tricked here? So sorry? Not exactly, but in a good direction. Okay, here is a randomization. So what it does mean? So with a good probability, you will destroy all subtree, because random returns you new bool value, and if it was size box and now it's container or opposite, you cannot update subtree, and it will destroy all the things. And we went in the third way, completely destroy those parts. So if we do this a bit more fairly and put all the same things, in this way we, to be frank, repeat the first example of benchmark. We will see also difference, not so big, but here's without const and here with const. So yeah, let's try to get a conclusion here. So const, in some cases like this, so we proved, to be frank, both benchmarks. Const here helped because it stopped rebuild of this subtree. But should I break my back and try to put const everywhere? Will it help? For example, here, if I put const here, I cut this part as well. But if somehow this one is also triggered to rebuild, my const optimization here doesn't work. So instead of trying to put const everywhere, you need to think about how to make this const work efficiently, that it makes its purpose. So stop rebuilding this subtree or stop rebuilding this subtree. And yeah, in this case, if we don't do this, const will not help us. So yes, I think we can fairly say that const are useful, but it's also logical that they remove it from the rules. So you can decide for your own application if you need this or you don't need, because the main part of the work framework, which you definitely use, it's done with all optimization, with all const. So yeah, you will get additional help from const, but it's your decision. And there is another good example. So also heated discussion. Some guy showed his improvement, which helped him go from here to here. How it happened? So he had a really complicated widget, which is triggered somewhere above, and yeah, all this subtree, huge subtree, was always rebuilt, and because of this, he had a really bad situation. So for some reason, I don't know, he couldn't use const somewhere at top, which I personally would prefer. But yeah, anyway, he managed to solve this problem a bit differently. He just cache value of widget inside specific widget, and if on his opinion this is not a case when it should be updated, he returned the same widget that it was before, literally reproducing the same behavior that we discussed with the const. So yeah, spoiler alert, I would not suggest do this, but it's a really creative way to solve the problem. This is exactly example of of smart engineering. You have a problem, you analyze this problem, you measure this problem, you find the concrete spot where is the problem, and then fix it. Fix it with, yeah, one of approach that you found good. So I don't think that the users really sorry about they fix it this way. They have seen this and now they see this. So it's a good decision. So let's go to the next one. But we discussed this topic that is obviously something that you work with almost all time. But what if we faced with the problem that's hidden inside the framework, or it's not a problem of framework, but yeah, it's somewhere inside. So yeah, exactly the same. Do an experiment and try to figure out what's going wrong. So here's another example. A bit complicated widget, this bunch of squares, different colors, and the button which does nothing. So you can see that's even not set state here. So you press and nothing happens. Yeah, let's try to run this. Oh, it's automatically run. So we are at the performance thing and we press. So yeah, it's quite a lot of resource consuming for do nothing, right? It's just one pressing button. You can see that rasterization is also suffering, but I can explain. So it's a low-end device with screen mirroring. It's understanding. But what's about the first part, this layout? Yeah, if we can see here, we have a even layout problem. So we have 22 milliseconds for painting something. So what we should paint there, we just have a small button that has a shimmer or some splashing effect. Yeah, here's a good tool inside the DevTools. So if you don't know, try to find a tool and measure something. And this tool shows what is painting. And as you can see, despite that changing only small part of this widget, of the screen, we repaint almost everything. And yeah, here we go again. We built our trees, and we have here render object. And the two main responsibilities of this render object is layout and paint. So you can see two of those things. And here is like smallest part is nothing here, so we can ignore, and the paint is suffering. Just worth to mention, when we say paint, in this case, it doesn't mean that we paint anything, because something that could paint, it's here, rendering. And painting is a description of what to paint in the end. So, and it's happening that way. We describe in a framework part what engine should paint. And to do this, we have layers. And initially, Flutter want to paint everything in one layer, of course. Despite you, even if you say it to paint in a different layer, it will. And you can do this in a few ways. For example, RepaintBoundary, or you can use another widget which has a render object that also say that it will be in a different layer. So yeah, here's a proof that a widget that creates a separate display list for its child. So it's moving to a separate layer. So if we do this and again measure our performance, we can see again rasterization is not something that we can affect here because it's low-end device with the screen mirroring, but our problem disappeared. Double check with our tool, and now we can see that pressing on the button, yeah, now repaint only those things. Oh, ideal tool, right? Probably we need to put them everywhere. Like, no reason to avoid this beautiful thing. But no. Again, no compromises. The problem is, so when you create those different layers, you can run optimization in a rendering pipeline. because the rendering engine should jump from layer to layer, and it will be complicated to it, and you will find another problem which even more complicated to measure and fix. So back days, I would recommend this tool if you finally face it, this problem with rasterization, but now it's impeller time, so Skia debugger will not help you. And yeah, predicting the question, I don't know which tools which help you with impeller. Maybe some native debugger, but yeah, I don't know. So what we can understand here, it's always compromise. You need to keep them a small amount of it's possible, but at the same time isolate with them really those parts which can affect performance. So, and the most important thing, measure the result and analyze it. And fortunately, Flutter already has something that helps us. So you can open, find this any render object that has this responsibility of moving to another layer and see efficiency. So is it useful or not? Amount of bad and good things. No, doesn't work. Magic doesn't work again. Oh, now it works. Yeah, and the last thing which I would show to you. So why important to measure always what's happened with the application, not only when you already notice the problem, but proactively when you do something. So does anyone see something problem apart from the, again, rasterization problem because it's a low-end device? So is it okay or not? We can just go with production to this. We can ship this feature like this. I can run it again. Any opinion? Anything? Everything good? No? If not, okay, yeah. So the problem here, nothing happened on the screen, right? So it's completely static, but somehow here we generate bunch of frames. Why? So yeah, this is a question that should appear always when you see something like this. If it's something that you do not expect, better do not better do not follow this pattern. It will not go away. It will stay with you to, like forever, and one day you will need to fix it. So the problem was here. So it's quite often pattern that people think if I hide something, for example, make this opacity 0, or maybe use a stack for emulating navigation. Do not use normal navigation, I just use stack and everything will be fine. And I don't see anything that happened, but all those things happen. For example, here, circular progress indicator always spinning. And yeah, we don't see this, but it's causing always work and wasting resources. So yeah, just a last thing, conclusion, no magic. Yeah, unfortunately, we see this, even this magic doesn't work sometimes. No silver bullets. You need to experiment, and what's important, analyze the result of this experiment, measure them, and validate them. Find the good way, understand which trade-offs you have, knows where's the bottleneck, where there can be a problem, and of course using right tools, because I cannot image how I could measure all those things without dev tools or those Skia debugger which I showed at the end. Yeah, just if you want the silver bullet for your application, be the silver bullet yourself. Your smart engineering will be. So yeah. As I mentioned, I have a recently YouTube channel, so you can find also videos. So I talk not only at conference. You can find this also in a like day-to-day videos. So yeah, maybe you will find something also interesting there. And thank you for your attention, and I'm ready to answer your questions.